In today's video, we have a truth table on the left of the screen, and we are going to get the logical function. In the first case, we are going to get the function as a product, a sum of products, and in the second case, we are going to get the function as a product of sums. So after getting the logical function, we are going to minimize it by means of the use of the Boolean algebra Boolean properties. Okay, so let's begin. If we represent the function as a sum of products, we have to see where the function equals 1. So in the first case, the function equals 1 when A negated and B negated and C negated. If we substitute these values here, we have A negated 1 and A negated 1 and A negated 1 equals 1. So it complies with the value of the function. The second one will be this row, from which we get plus A negated and B negated and C. So we continue with the third row, from which we get A negated and B and C negated. The next one could be A negated and B and C. The following one, or plus A and B negated and C negated, or this one, A and B negated and C. And the last one, this row, or A and B and C negated. So by using these Boolean properties, the first 4 rows on the right table, and by using the De Morgan's law, which is given in this row, we are going to try to minimize this function. We can use, to minimize this function, we can put some terms together as if we were using arithmetic in maths. We can use the arithmetic laws, distribution law, commutative law, and associative law is useful to minimize these kind of functions. So we can see, for example, that this term and this term have A negated, B negated as common factor. So I'm going to name this 1. In the same way, we can see that this term and this term, which I'm going to name it 2, have A negated and B as a common factor. And in these terms, this one and this one have A and B negated as common factors. So from here we're going to take those common factors out, and we are going to manipulate the corresponding function by the use of the table on the right. So from the first one we have f equals A negated and B negated, and this is my common factor, C negated or C. From the second factor we can get A negated and B as common factor of C negated or C. From the third one we have A and B negated as common factor of C negated or C, or the remaining term, which is this one, A and B and C negated. Okay, so from the table we can see that A or A negated equals 1. So here this term equals 1, this term equals 1, and this term equals 1. And here we have A negated and B negated and 1. Okay, we will have the following: A negated and B negated and 1, or A negated and B on 1, or A and B negated and 1, or A and B and C negated. Okay, but from the same table we can see that a term ended with 1 equals A. Okay, so from here we can get f equals A negated and B. By using this, A and 1 equals A, so here we have A negated, B negated, and 1. So I get this factor, or A negated and B, or A and B negated, or A and B and C negated. Okay, but now we can see that these two terms which I'm going to name 4 has A negated as a common factor. So we can rewrite the function as A negated and b negated or b, or a and b negated or a and b and c negated. But again, in this case, I have that this equals 1 by using the same property I used before, which is this one. Okay? So I rewrite my function as a negated or a and b negated or a and b and c negated. So we could think that this is the simplest form of the logical function we are trying to minimize. But we have another ace under the leaf, and that we can use the De Morgan property, which is this one over here. Okay, sorry, this one over here. I'm going to negate this function twice so that I don't alter the value of the function. Okay, so let's do it. So we negate this twice. I repeat, we have to do it this way, not to alter the value of the function. And from this equation here, with the first negation, we are going to use this. So we can rewrite this the following way. F equals a negated, sorry, F equals a negated, okay, because from here we have that an OR operation negated, I can rewrite it as an AND operation with both terms negated. So here I have two sums, and I'm going to turn it into three negated terms added. Okay, so from the first one we have a negated and and a and b negated and a and b and c negated, and I have to write the first negation, the upper negation here. Okay, this equals a and a negated or b negated or and sorry, a negated or B negated or C negated negated. And I have to rewrite the upper negation again. So from here we have that this equals A and A negated or B negated negated equals B, and A negated or B negated or C negated negated equals C. Okay? And I have to rewrite the upper negation. So I'm going to multiply these two factors so I can continue minimizing these terms. Okay, so we have this, that this equals by using the distributive law. I have A and A negated. Okay, or A and B and A negated or B negated or C. And I rewrite the negation above. So here I have that this term, okay, by using this Boole's algebra property, I have that A and A negated equals 0, so this equals 0. Okay, and from here I get that F equals A and B multiplied or ANDed with A negated or B negated or C with the upper negation again. And by using distributive law, I multiply this term with the inner ones, and I get A and B and A negated or A and B and B negated or A and B and C. So from Boole's algebra, look that a and a negated equals 0, and 0 ended with another term equals 0, and from this I have that a negated and a equals 0 ended with another term equals 0, so this equals 0. V and v negated equals 0 ended with another term, this equals 0. So from here I get that the minimization equals a and b and c negated, which by means of Morgan's law, this one, I can get the final result, which is a negated or b negated or c negated, which is a 3-input OR of 3 negated variables. This will be something like this. If I have a, I negated, I have v, I negated, I have c, I negated, and I put this into a 3-input OR gate, and I get the function f. So this would be the minimized logical function from this original one by means of using algebra, Boole's algebra theorems and De Morgan's theorem. The second way to do it is by getting the logical function by means of the product of sums. To do this, we have to see where the function equals 0, which is this term, and I would write f as the terms that produce this 0, but all of them ordered, all of them with an OR function, and by negating these terms. In this case, I will write a negated, not a as in the previous case, but a negated, or b negated, or c negated. If I had another row which produces a 0 in the function, I will write it here ended with this one, and so on. In this case, I have this only combination which produces a 0 in the function, and this will be the function obtaining it by the product of sums. Look that in this case it is minimized, as it would be logical to think that we will get this minimized function, because here I have only one row. And this is the same result we get from the previous minimization in the previous case. A negated, or B negated, or C. Okay, so that's all for today's class. I hope you liked it, and see you in the next video.